Good morning. How's everyone doing? Good afternoon. It's 1 p.m. Knoxville time. If you're in the chat right now, feel free to say hey. Let's see right here. I'm going to try to get something going right here. I wonder if I can play this. Let's see. I have to, won't be able to record it. Oh. Yeah, I can't record it right now because I need to. I can't get it. Because, yeah. Well, darn it. Because I'm wondering, hey, Kaya right there. Colton, good to see you. Laura, good to see you. I think, Colton, you sent me some stuff, right? Let me take a look at, Colton, let me take a look. Where is it at? There it is. Okay. I have a question on 5E. I'm sure what code to run. I think it's associated because there's quantitative Y and categorical X, but I could be wrong. Also unsure what kind of code is needed to visualize the model because visualize model did not work. Let me go ahead and take a look at this. Colton right here. You were sending me stuff last night. Awesome. Thank you so much for that, Colton. I've got your stuff up. Patsy, great to see you. Drop questions if you have in the chat right now. I'm going to take a look at Colton's questions. Colton, do you want me to not display it? I can not display it if you want. 5A you were wondering about. Okay. So regression has the abilities well beyond basics to try these more advanced models. Here we go. So create a model predicting a quantitative Y from the interaction. And so you won't use associate right there. So Colton, you won't use associate. How do we create? And let me walk through this right here. So let me talk about, this is 5A. Oh, you don't mind? Awesome. Let's do this. This is 5A for, so let's go here. And we got 215 BAS 475 question 5A assignment 2. Is it tougher assignment? Let's do it. Okay. So what we're talking about right here is, and maybe I should show, is, I'm going to show something really quick. So check this out, Colton. Are you ready? I got to be careful how much I play of this. You ready, Colton? So this is what we finally created with the help of Dylan with some stuff right here. I need to get what he did. He changed it around a little bit and made some advancements. We keep updating and sending it. So you ready? Watch this. I gotta hit the music here. So I don't want the music to play and us get DMCA'd so quickly. I might even, but yeah. So I don't know. So that's what we created, Dylan, right there. You start the timer and it. So yeah, but it plays the final countdown while it does it, and then we were even doing this shiny up. But I love the strobe effect, which I think is pretty neat. That every second it does a different random pattern. Yeah, it's a lot of fun. And then it says countdown complete, and we were looking at updating other stuff within this. So we were looking to make more updates. It's Dylan's code right here that did the set background color, and then I used a rainbow palette to pick more things. So it's mad like an association right here. Argument alpha is missing with no default. Well, that's fine. Alpha, sure. Saying alpha missing with no default. Alpha equals 1. There. Now it can be happy that it has an alpha argument. So I don't know why I was so mad about that. Anyways, so that's what we got going on right there. And so for 5A, little neat thing that people get to see right there. 5A is talking about making linear models. So associate is a really good function that's in reg class. So library reg class has in it some really good stuff like the associate function. You can view the associate function right here and see what it does. Does a lot of visualizations for us that are pretty quick and easy, but it doesn't do some advanced visualizations. What we want to make for these questions that we're about to talk about is a linear model. Now we need some data to make this linear model. I'm just going to pull up random data right here. Can't remember which ones I used for this example. This data is inside of reg class that I'm using. So we're about to just pull up a data set that's inside of reg class. I'm not loading data from a CSV. I'm like saying, okay, R has access to this data inside of this package. So I'm going to then load this data right here. And just so you can see, so we only have that data showing, we're just going to load the data. That loads data that's inside of a package. The data function loads data inside of a package. It's not a CSV file on my computer. It's R has this inside of its brain right now. And I'm saying, go inside of reg class. So if I type data, you can see the data function just shows you all the different data sets that are available to you. And they're usually inside of different packages. Like it'll tell you this is inside of Lubridate, that's inside of reg class. So you can see it's right here. And if you have questions, let me know. We're going to talk about this a little bit and then we'll go on to another thing. So we are using Survey 9, which is a Stat2 survey from 2009, like 13 years ago. Ha ha ha. It gets older every year. As do I. And we have different variables. We can see most importantly the variable type. And I believe this one is doing logistic regression. I believe you're doing logistic. So when we do, and this goes to 201, when we do a model, so that stands for linear model, it stands for save into the object M. So that's a left arrow, save into object M, the linear model. And I'm going to do XO2 weight. And I'm going to do by XO, oh, that's not, it's XO3 weight. And I'm going to do X, and those are capital X's, watch out, XO2 gender, data equals, and survey, and just give the data frame. Okay, so it ran. You also make sure things run. Y tilde X comma data equals. Make sure you know Y tilde X comma data equals the name of the data frame. Is this, Colton, is this ringing a bell right here? Y tilde X comma data equals. That's the formula format to say my Y variable of interest. I want to understand weight. The X is what's explaining weight. And then the data right here is the data frame the variables come from. So it knows where to find them. It's saying we want to do weight, XO3 weight. We want to do gender explaining it. There's the X variable. Y tilde X comma data equals. So what's interesting is if we want to add in more variables right here, we could just say, let's also add in somebody's height. Do we have height? We don't. Let's add in their GPA. There we go. Now, if I misspell it and I run it, it says it can't find GOA. So we need to put in GPA. Now it can find it. So Y tilde X comma data equals, make it a little bit easier to see. This is the formula format right here, Y tilde X plus X. But we don't have to just do the two variables. We could do the two variables and their interaction. So that's how you do an interaction right here. So let's take a look and put some notes right here for us. To differentiate, this is going to be simple linear regression, and we can view this. So we go here to visualize model and visualize the model. And we'll just put this in. So this is simple linear regression, which means we just do a Y by X. Chapter 7 coming up here for Stat 201. Simple linear regression, visualizing Y by X. So you can see generally people with higher GPAs generally have a lower weight. Doesn't mean these things cause each other, because probably the lurking variable there is gender. To a certain extent, we would think maybe. We'll find out. So now we can go right here, and this one is going to be linear regression, but with indicator variables. Because what would we need to indicate in this model? Now we're adding in a categorical X. We would need to indicate somebody's what in this model. Think about what an indicator does. It's a categorical X. And so now we have linear regression. So we're adding in another variable from this model to this model. We would need to what, if we add this variable to the model, we would need to what somebody's what in this model. We need to indicate somebody's what, because now it's a variable. It will differentiate between different groups. So we'd need to indicate somebody's what in this next model right here. We need to indicate their what. So when I make this model, it'll allow us to indicate somebody's what. So before I visualize this, be like, okay, now it's going to have the ability in this model to indicate somebody's what. So what is it going to indicate for me? From this original model right here to this next model, what's the additional thing that's added that will allow me to indicate? Which, since it's categories, it'll indicate between those categories for us. So, exactly. Great job right there, Colin. Some points in the chat. I think Meebot's awake. He's probably awake. If you have questions, let me know. Oh, I got the sound effects turned off. There it is. And so now we visualize it, and there you go. Still works that way, even for both genders, but we'll add in here an interaction here in a second. But you see right there, generally higher GPAs are associated with lower weights. But wait, there's more. Oh, I did the interaction. Whoops. Let's remove the interaction. And there's no interaction. And then here is with interaction. And interaction. Now, an interaction allows for the variables to have different slopes. I kind of looked at the lines. I was like, wait, the lines should have the same slope if there's no interaction. But if there is an interaction, they're going to have differing slopes. So the star right here puts the interaction term between them, which allows for there to be the way in which Somebody's weight is impacted by GPA depends on gender. And the stronger the interaction, the more perpendicular the lines. So the stronger the interaction, the more perpendicular lines. I feel like there's a delay on my switches over here. So Colton, what are you thinking? This is how to make models right here with Y's and X's. And if you want to summarize these to look at the coefficients in the model, you can go to summary and see the impacts of the coefficients. So the only thing that's actually significant in this model is GPA. Could be due to multicollinearity or stuff like that. But GPA is the only significant variable in the model right now. So right there with the p-value, which we kind of talked about in tool 1 a little bit today, but GPA is the only statistically significant thing in this model. What are your thoughts? What are you wondering? What questions do you have? Summary gives you the output of the model to tell you, what are your coefficients in the model, and then also visualizing is going to let you see your model. So what are your thoughts, Colton? Let me know what you're thinking. And great work on the assignment. Like, you're way ahead of schedule. You're asking those questions, you're reviewing, and that's what we're here to do. Practice, review, and learn. We're talking about standard deviation today in Stat Tool 1. And let's do this. Watch this. So Patsy, or if you're here, could you... Ooh, got a big outlier. Dang it. Let me go to... We don't have height. Hey, Brian, I have a question regarding the quiz over type 2 assignments. I have trouble finding the standard deviation on the... Yeah, which one are you doing? So if you were to estimate standard deviation right here, removing the outlier, like there's someone with a weight of close to 500 pounds. And let me look at Colton, the question. I think it is the second code I did. Let me look at the question, Colton, real quick. No, I'm going to ask the additional one. I got way too much open. What is it called? Here it is. Oh, wait, that's not it. Here it is. Okay. 5A, right? 5B, or you said. Create a model predicting a quantitative Y from the interaction of a categorical X and a quantitative. So it's the interaction one I just did, the interaction stuff I did. So let me go back to here. It's the interaction stuff I just did right here. Does that make sense, Colton? And then I've been wondering what is going on. No, Patsy, let me know. This is the senior level class. And here's a good question, Patsy, which we can then, in Kevin's question. Kevin, do you have a specific one you want us to do? We can do the standard deviation. Pick a question, say it starts with this, Brian, and we'll jump right into it. But if you had a test question that had you estimate, I'm going to make it easy on everybody. If you had a test question that had you estimate the standard deviation, what might be an estimate of the standard deviation? So who has a way, and if you're in the morning class, you might have a way to estimate the standard deviation for this. So I removed the outlier. What might be an estimate of the standard deviation? Without that outlier, which is going to inflate standard deviation, what is our way of estimating, which is just going to give us a guess of the standard deviation of this? So this is we're just going to get a guess of the standard deviation. Divided by 6, so we take that histogram right here, divide by 6, and so we're going to take... right here, 300 divided by 6, which 0 to 300. Maximize new and divide 100 points. People following Jessica and Patsy. Great job. And we're going to start doing a center for it. You bet. Let's do that one next. We're going to do that question. You got it, Kevin. So 300 divided by 6 is our estimate. It's 50. And the answer is 37. It's not exact. We got further off than we did in class, but on the test, like you'd be able to say, oh, it's like that. What do you think? GPA, if we do here, $, don't we have a GPA one? There we go. So, oops, oh, don't look at that answer. GPA ranges from 1.2 to 4. Or so GPA goes, so the range is 4 minus 1.2 divided by 6. Oh, wow. Look at this one. Does this make sense right here? This one is, I did about the range of the GPA. So there's the range from 4 to 1.2. I divided by 6. The actual standard deviation is this, and here's the estimate. Once again, that's just an estimate. Sometimes it's pretty good. Sometimes it's not so great. But what do you notice? GPA has a much smaller standard deviation. It has a much smaller range. Standard deviation tells us about how far things are usually away from the mean. This distribution is skewed though, so I'd use mean and IQR. We'll jump into Kevin's question, but just a real quick thing. Does that make sense how we just can estimate it? And we should know that standard deviation is a measure of spread that's associated with the mean. And then we can tell how things are generally far spread out from the mean. Usually a bigger range will indicate a bigger standard deviation, which we saw between this distribution having a very small standard deviation right here, 0.48, and this distribution right here having a very large standard deviation, 37. This one has much more variation in the data compared to this distribution right here. Awesome. Colton, we'll come back here and we'll do that next. You got it. We're going to go do the Center for Education. And so drop those questions in the chat. We bounce around, and thank you so much, everyone, for being here. I'm going to throw another 100 points in the chat. We've got a Center for Education question for SAT 201. And let's go check out the Center for Education. Getting the assignments up and going. And you will be everyone's biggest. They'll be like, oh my gosh, thank you so much. Because it helps a ton to have the questions in here. So let me take the timestamp. I need to, whoa, that thing's going crazy right now. Replace questions. Center for Education. We're going to find that right here. And, oh, Kevin's got all their numbers. Well, we're going to show you how to get those numbers in the chat right here, or get those numbers in. So, 17 on the dot. 1701. Stat 201, Chapter 2, Center for Education. Well, let's go check this out. Center for Education. I'm going to find the question real quick. Hurricane data. Where is it? Found it. Let's go do it. Here we go. Okay, the Center for Education, and we have a bunch of values. Now, I'm going to show you some tricks for this question that are really great. One, if you do this question in Jump and you get it wrong, let me know. Because Q1 and Q3 come out a little bit different. But here's a trick to get Q1 and Q3 right every time with this question. Down here on the very bottom, it actually gives you Q1 and Q3. Also, we can find them by hand. Let's find them by hand like it's a test, and then let's check our answers down here. So the first thing we're going to do is we're going to copy the data, and you notice it's already in order, going from lowest to highest. So when we copy the data, we're going to copy to the clipboard. Kevin's already got theirs in the notes right now, so let's take a look. Copy to clipboard, hit Control or Command C. It's copied. You could bring it over to Excel or Jump because we're going to mainly use this to solve right here. And let's go right here to a data sheet and then go to File, New, Data Table. I'll pause on the screen right here. We're just going to put it in the data sheet to look at it and then solve for the answers. So here we go. Boom. Now we hit Edit and Paste. Make sure I have a new data sheet and paste it in. Awesome. So now we have the data pasted in, we can see it. So what's the deal with the data? Well, we have 22 observations. Now watch out. If there's 22 observations, is there a middle number? Well, since it's even, like if there's 10 numbers, there's no middle number. So that means we kind of have the lower and upper what? So this is where I pause, make sure to answer this. We have the upper and lower. How many numbers would be in the upper and the lower? Like we have like the upper amounts, like upper this many and lower this many. Because if we have 22 observations, we'd have the upper this and the lower this. How many observations? I've got to kind of highlight so you can see the answer over there. So we kind of, if we have 22 observations, we could cut it in half and have the upper this and lower this. Passy, great work right there. Another 100 points in the chat. We have the upper and lower 11, right? So how could we find the median of this? How could we find the median? So solve right now for the median like this is a test question. Remember, always put them in order. And then if there is no middle number, which there's no middle number here, find the median. I'm thinking right now, I'm thinking of the median. So 8.5, I think I know it. 506.5. I think I know it. Double check my work. Let's see what people get in the chat. See if you can solve the median. So all you're going to do is average together those two numbers right there, because you just take them and you average them to find, since there is no middle number, take those two numbers, average them. So what would that be? I think I know it. I think it's 506. What is it? It's not 506. And don't round anything. Don't round anything. If you ever think something's wrong. Great job, Kevin, right there. Excellent work in the chat. It is 506.5. We're going to average together the two middle numbers. Always practice right here. The more you practice, the easier it is on the test when you get to it to say, okay, I just average those two numbers and make sure you get what I get. And there you go. Now, here's where I would do this by looking at it, and that's we never do Q1 and Q3 on the test, but pretend, because we don't do it on the test, pretend you have the lower data. Now that there's 11 numbers, there is a middle number. So with just 11 numbers right here, yeah, we could do that here in a bit, Troy. You bet, Troy. Actually, that might be next. I think, Colton had a question, and then Troy, we can do yours. So with this right here, the middle number is now this. Does that make sense? Because how many numbers are above and below this number? Telling us it's the middle. Notice there's this many above, and we're just looking at the bottom data set, the bottom 11 right now. So just looking at the only bottom 11, how many numbers are above this and how many numbers are below this? It's perfectly symmetric around that now. So we don't have you solve Q1 and Q3. Great job on the test. We don't have you solve those on the test because there's differing methods. It drives me absolutely crazy that they do that. Then we need to get there we go. So we're gonna do the same exact method right here. We go 1, 2, 3, 4, 5, 6. Ooh, no, right there. I don't know how I counted too many. 5 above, 5 below, 549 is the answer. So 549 is the answer for the top 11. And so once you get these, here's what I would do on this question. I'd go down here to the bottom, zoom out a little bit. Do you see this right here? 549, and we have here 441. That's the way to confirm your answers. The ways to confirm your answers are to practice finding them and then confirm your answers down there, and you know you have it. Now, the easy thing to do is the max and the min. The min is going to be 196, and the maximum is going to be 607. The 5-number summary is the lowest number, the Q1, the median, the Q3, and the max. These are the 5 numbers we're finding right here. The IQR of the distribution. Who here can put the math in the chat for 100 points? We're just going crazy on those points as we usually do. Join office hours, get some crazy points. What is the IQR on this? How do we find it? Solve the mathematics. Remember the formula for IQR is Q3 minus Q1. So that's where the 75th percentile is to the 25th. It's just a distance. Remember, IQR just stands for interquartile range. Visually speaking, you're just taking. I might need those numbers. Instead of going from the lowest number to the highest number, which is max minus min, the IQR is just the distance these numbers are away. So that's the IQR right there. It's a range of the middle 50% instead of the range of the whole data set. So when people are, great job, love it, I'm clicking the extra button right there. Everyone is finding it. Hopefully it's not too loud for you. People are saying we take 549 minus 441. Who here thinks finding the IQR is easy? Like maybe before this class, you're like, how do I find the IQR? And it's like, oh, it's just how far those numbers are away. It's just a range of these numbers. Instead of the full range, you just do those 2 numbers instead. So it's the range of the middle 50%. Just repeat it in practice what it is. So the mean is a little not so fun to find by hand. This is where we actually are going to use jump. To find the mean of the data set, so I'm going to slow down a bit here. To find the mean of the data set, make sure you've pasted the data into jump and make sure it's quantitative, i.e. this is blue. If it's not blue, try repasting again or contact me if it's not working because you have to make sure to paste and paste properly. We're going to go here to analyze and then tabulate. Analyze, tabulate allows us to get statistics on certain metrics. So we're going to go right here. Then we're going to click column 1. I can't double click it. We'll drag and drop it right to here. That gives us the sum, but we don't want the sum. Watch again. We're just going to drag and drop it right here. Just drag, drop right there. That's how much there is. We could divide that by 22 and we'd have the answer. But, yeah, nice job, Colton. Colton, 50 points right there. We're just going to then drag and drop mean and put it over that. There it is. 477.9. There we go. And guess what we're going to do? Using the same platform right here with the tabulate, we can put this below if we want. Oh, we could put it right there. I think Alexa's talking to me. Standard deviation is 96.15. Just, you can just, I'll start it over and show you again. You can just drag standard deviation right here. And there you go. 96.15. Don't find standard deviation by hand. Don't find standard deviation by hand. Our trick doesn't work so perfectly here. If you look, it has a range of about 400. Well, 400 divided by 6. What is that? Wait. That's not right? It's not that close to it. Doesn't turn out so perfect every time. 96. I keep hearing Alexa beep. I'm just going crazy. 96.2. Determine if the distribution is skewed, symmetric, and describe the middle 50% of the scores. Okay. Let's look at it. The easiest way to look at the distribution. Is it skew on here? Oh, that's a bummer. It doesn't show skewness on that. The easiest way to look at the distribution is to do the following. That's very obvious one direction. Okay, so which way is this skewed? Ooh, take a moment in class. Can you show? Yeah, I'll show you here in a second, Kevin, again. Yep, I'll do those steps again. What way is this skewed? Watch out. What way is this skewed right here? Not that. What way is this distribution skewed? Good. We did this. Oh, Jessica, 100 points. Yeah, Jessica got it. Then I'll show it again. Jessica, 100 points. Thank you for answering the question in the chat. Jessica, thank you so much. That's exactly what I want students to do while they're watching and helping each other out. So what way is that skewed? Oh, Kayla, we tricked you, Kayla. Don't worry. We're practicing that. Don't worry. 50 points in the chat. We tricked a lot of people. What's the saying? Right to the high. Oops, I'm about to do it too. Right to the high, left to the low. Whatever way the tail goes. Don't worry. These are the trick questions where people get it wrong on the test and they're like, no. We did this one today in class. Right to the high. I know it. Right to the high, left to the low. Whatever way the tail goes. So what is the See, I'm doing it every time. I'm finishing my second cup of coffee. Kayla, great to see you here. Drop some questions in the chat if you got them. We did a little 475 to start. Oh, you're in 320, right? I thought you were in 470. I thought you hadn't seen all the classes. Yeah, but you're doing great. Don't worry about it. So what's the problem with this right here when you do this to it? What is the problem right here? And so we showed this today in class too. I did this trick that catches people a lot of times. Do you notice the problem with the number line right now? Why when you're like, oh, let me just turn it and it's right skew. It's actually left skew. Why? Because the number line right now is what? This is the common error on this question. Very easy test question to make a mistake on. The number line is mirror image. Does that make sense? Yep, exactly. It's mirror imaged. It's like it's a flipped number line. And I did that trick question today in class, and don't worry if you got it wrong. Over half the class got it wrong. So we're not trying to trick people. It's just the way data looks sometimes. You just have to be careful. Right to the high, left to the low. You just have to make sure the number line's oriented properly. So what you could do right here is you could go to analyze distribution. They're not trying to trick you. It's just there's many ways to display data. And it's very clear right here that it's what skew now. Very clear. Say it in the chat with me. This is showing the same thing right here. Both of these are the same graphic. This number line is oriented properly. It's very clear that this is what. Look at this one, which is oriented properly. It's very clear that this is what skew now. So it's very, very clear that this is what skew. Very, very clear it's this skew. Because the tail's going to the low side. And you can see the tail on the low side here too. But it's very, very clear this is what skew. Left, 100 points right there. Very, very clear it's the left skew. No, don't be scared. Don't be scared. Don't worry about getting it wrong. I want everyone. Here's another 50 points. Don't get it. Don't worry about getting it wrong. There's a billion things to practice. I felt so bad. I told my fiance I was working with some people on some research, and I actually used the mean instead of the median for skewed data. And I was like, I tell my students this every semester, and I was using the mean instead of the median for skewed data. Like I teach this to multiple classes every semester, and then I was using the mean instead of the median because the data is skewed, because the first thing you look at is the shape. And I was using the mean instead of the median because the data was very skewed with outliers, and I was using the mean, which is the wrong thing to do. And I teach it and I say it like so many times, but I just went straight to the mean and didn't think about the shape of the distribution first. Like, what's the first thing we look at? The shape. So don't worry. These basic things are things that are so, like, we do so much that we just forget about sometimes. So I was beating myself up, and my fiance is like, don't worry. Sometimes you caught it. You understood it. Oh, I was beating myself up over it. The data is skewed because the mean and the median are not approximately equal. Watch us get something wrong. Ready? Oh, we didn't. I was hoping we get something wrong. So that's got this question right here. Really good question. Really good practice on some concepts. We should use them. Let me ask one last question here. 50 points. I know it's getting crazy again, right? Got to get it cut before April for the wedding. So What is the proper measure of center for this data? Not today, my Pearson, not today. What is the proper measure of center for this data? We just called the data skewed. So what is the proper measure of center? Good test questions right here. What is the proper measure of center? What is the proper measure of center? We just called the data skewed. And this is where I made a mistake. If you get this right, you would have gotten it right and Brian wouldn't have. The data is skewed, so what's the proper measure of center? Median. Kevin, great job right there. Kevin, you got it. It's median. So then what would be the proper measure of spread, which is paired with the median? Here's the median right here. So think about what else we just talked about, which is near the median. What's the proper measure of spread, which is near the median? Well, it's not like near, but you'll see it in the output. If you do the analyzed distribution, you will see the median right here, and then right around it, you'll see the IQR. Because the IQR is this distance right here. Notice Jump does it a little bit differently. I wouldn't use the numbers from Jump, but if you get it wrong because of Jump, let me know. I'll give the points back. Kevin, I think you were asking about the tabulate. Tabulate. We're not going to tabulate that. Let me know your additional questions. I think we have 2 more questions. Analyze, tabulate, and then you can just drag and drop to get the numbers. Thank you, Kevin. That's our goal right here. Just some practice and get answers and then see how to find them and then just boom, 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 solve it. Yes, I'm throwing 100 points. Jessica, thank you so much. And feel free to always answer those questions for people. I always throw points when students are helping students. I think the next question was from Colton. Let me get Colton's question right here. We have opened, I think there's one more after Colton's. Colton was wondering about, and then Troy said, let me put those down. Let me get Colton's question. Oh yeah, R basics. Yeah, we do some R basics. Yeah, Kayla, definitely. Troy's wondering about the visualization 2, and Colton was wondering 3C. Let me write those down. So 3C for 475, visualization 2, stat 201, and then R basics activity. Okay, let's start this up with some 3C. Let's go over here to the main screen. Okay, let me get the timestamp on this and drop more questions in the chat. Remember, we're going to have open questions again here after these, so we probably got enough time. 3C, so assignment 2 and 3C. Okay, question 3C. Let's do this. Let me find the assignment. 3C. I need to find it. Okay. Cool. Let's go check this out. And thank you so much, everyone, for being here practicing. Take a look at what we're talking about. Compare the values of weights for right and left-handed people and clearly interpret the results. So what we need to do right here is we need to compare some values. Now, I'm not going to do exactly this, but if we compare values, we could probably compare what's for groups. What do you think? If we want to talk about, like, let's go look at genders right now. Let's go look at, let's go to survey 10, actually. So once again, Brian often does similar, but not quite the same work. So don't copy everything I copy, especially in the upper level classes. I'm always like trying to have you do more work on your own. So I'm kind of just talking the concepts right here. If we were to talk about somebody's gender right here, we collected data from these individuals, and we have here gender, there's their genders. Does that make sense? If we ask these people, survey 10, their weight, there's their weights. All you're looking at right here for 201 and other classes, what does this look like to you on the screen right here? What program does this look like to you? Does anyone think this looks like another program? Like, here's person number 1, they were female, they weigh 160 pounds, they want to weigh 155. This person 2 is, which that's kind of the identifier right there. Like person 2 would identify who they are. So the row number might identify. They text 100 times a day. They're on Facebook 60 minutes a day. This is back before Snapchat and TikTok and Insta and all the things. Everyone's like, yeah, Facebook. Now Facebook's the old person thing. So what is it? It looks like Excel, right? It's just Excel. That's all we're working with. It's just Excel right here. That's all we're working with the upper level classes. Just Excel. So this is the name of the Excel spreadsheet, and this is the variable inside the Excel spreadsheet. Does that make sense? So we got here the name of the Excel spreadsheet. It's called Survey 10. It looks like Jump 2, right, Jessica? Great work right there. Looks like Jump, and then we got the name of the variable right here, and look, they're connected by dollar signs. autocomplete is so nice when you type survey and then you go here and then you do this, boom. What's interesting is we did contingency tables today in class. If you do a table, you can actually make a contingency table of things like this. I believe this should make a contingency table. I don't make a ton of them, but we can make a contingency table of somebody's gender and handedness just by saying make a table of these variables. Do you say the Facebook? I think it is, right, Kayla? I don't know. Maybe we're big fans. I don't know. I'm just a YouTube person now, but I was on Facebook all the time playing some Mafia Wars and stuff like that. I don't know. I was like click, 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 click. So it's kind of sad. I was on Facebook way too much. So right here, now that I think my parents use Facebook. So if we want to talk about people's genders and people's weights, what could we compare between genders and weights? What could we compare? Farmville, oh, that was so big. Yeah, Farmville was crazy huge. Some points for Farmville in the chat. So Farmville, got to grow those crops and everything. What could we compare between people's like, I could look at, we only have data on males and females right here. So we could look at males this weight and females this weights. And you'll, Kayla, you're about to hear some 320. 201, you're about to hear some review. So we could look at what's and what's. I want to show you how simple the code is. And we'll see some words from today from 201. What do you think we could compare between like males and females? Males this weights and females this weights to compare and see which one weighs more. Males this weights. It'll be interesting to look at desired weights, because not what people weigh, but what they want to weigh. So what do you think we could do to look at a typical person? Great, Kale, you got it. That's the exact. We could look at mean, or we could look at what 201. Remember, this is, I'm trying to connect all the classes. We could look at mean desired weight, or we could look at what? We could look at mean desired weight, or we could look at what desired weight? You're on the right track. We could look at mean desired weight for males, and mean desired weight for females, or instead of means, we could look at what? So we could look at the mean, like what's the average desired weight, or median. That's exactly it. And this is something we'll be doing in your class. So check this out. Here's the function. Are you ready? Associate. Associate is in the red class package. So make sure you have library red class. Kayla, you'll be doing this. This is a review of 320 from 475. This is a review of what you'll be doing here in about 1.5 weeks or so. 1.5, 2 weeks, you'll be doing stuff just like this. So here's the code. Are you ready? We have y. So I'll write right here, y tilde x, comma, data equals. Colton, will they be using this format, y tilde x, comma, data equals a lot? Y tilde x, comma, data equals. Y tilde x, comma, data equals. I know, Jessica, you got it right there. So many great answers. Y tilde x, comma, data equals. So a lot. So y is the name of the y variable. X is the name of the x variable. We just put in the y variable, the x variable, and then data frame. What do you think? What data frame am I going to call? Where is this data located? I've heard you say it like 500 him. Y tilde x, comma, data equals. Y tilde x, comma, data equals. Where's that data located? What's the name of the data sheet it's located in? Y tilde x is the variable names. And then we do data equals, and we just say what data frame it's located in. So what's the name of the data frame my variables are located in? So the y, the x, you got it. Survey 10, we type it. It auto-completes. We click enter, and then we go. And here it is. We're going to make the graphics a little bit bigger, and here's the results. Okay, let me make it so we can see it. And I'm just making it so the graphics are a little bit bigger. Let me rerun it so it does the graphics again. We get a little bit better graphics. Now, I'd like for you to notice something. 201 and 320 and everyone, what is the first thing we look at when we're analyzing distributions? The first thing we look at is what? I'm not joking. We literally talk about this in 201. The very first thing we talk about when we talk about distributions is the what? The shape, Troy. Yep. This goes back to 201. Jessica, Troy, everyone, shape, you got it. So tell me, how do these distributions look? Now, if you're in the upper level classes, and you'll see this in chapter 5 and 201, this is called a normal quantile plot, which shows us what a normal looks like by the red line, and if our data follows it. You notice how our data is not following it because of the right skew? So this data looks to have outliers, looks to be skewed to the right because it's pulled to the high side a little bit more. There's a little more of a, the male, is that the female distribution? Female distribution is a little more right skewed than males, but both of them look to have some sort of deviation from normal. This plot right here, which a lot of students forget and don't know is called a normal probability plot. But read it backwards. The probability that the data is normal, the probability that the plot is normal. If it follows the red line, it's normal. The less it follows the red line, the less normal it is. Do you notice where it follows the red line a bit and it looks kind of normal? And then when you get the skew at the end, it starts to deviate towards the end of the data. This one's a little bit more normal, but there are some high outliers over here behind my head. But it's more normal for the most of the way till you get to these high outliers here up here in this data part. So in 320, look at the QQ plot. So we call it for short quantile plot, but normal probability plot is what we call it in 201. And it looks not too normal. I'm not going to talk about the permutations. That would be a much bigger talk for later. So here's the thing. I just want you to think about this data. So since the data is skewed, should we compare the median male or the mean male? So this goes back to 201 and to the, since the data is skewed, what should we compare? We took notes today. What should we compare between the two groups? Since the data is skewed, we're literally using 201 notes to help us out. Since the data is skewed, we should compare the what male versus the what female, the median. So guess what? When we talk about what do people, great job, points in the chat, people practicing. So guess what? Does there look to be a pretty big difference between the medians right here? So when you say to males and females, what do you want to weigh? This is what the question is what do you want to weigh? And we only have data on males and females here. So we say, what do you want to weigh? And you'd say the median male wants this more than female. Interpret that difference right there. So I think it talks about interpreting the difference because we always want to give the data context. Well, we talked to males and females and the median male wanted about this compared to the median female. So what do you notice right here? Males want to weigh more and about how much. And so Kayla, great job right there. And then give it context about how much, which is we always interpret the practical significance. Is it a big difference? Or is it like, males want to weigh about 2 pounds more than females? Like the 50th percentile of males, the typical male kind of measured by median, is this a very small difference or a very large difference between the typical male and the typical female? And typical doesn't mean everyone follows this, but like 50th percentile, 53 pounds exactly, and just subtracting these differences right here will get you the practical significance. And then we could say to our bosses, I would say like that, about 50 pounds, right? Like males want to weigh about 50 more pounds than females when we look at the data right here. And then for 320 and 475 right now, that difference is unlikely by random chance. The most likely difference by random chance, if it's just random differences, would be what? What would be the most likely difference by random chance? Which we could actually probably see that if we did something like, I don't know. I got to find something that's like very random between males and females. A lot of these, there are differences between males and females. Age of first kiss would be interesting. Let's see. Is there a difference right here? I'm going to see if males and females have a difference. It's X16. Oh, no, that's the wrong data set. I'm in the survey 10. Males and females are probably similar. There's so many differences between males and females. I think there's all differences. Like if you ask males how much funnier they think they are, there's a difference. Oh, this is linear, sorry. Oh no, I changed the wrong one. Does gender explain percent funnier? So percent funnier then. Here we go, it's doing it now. Males think they're a bit funnier than female. Like, not saying they are. It's just perception. This is own perception. Low, yes, exactly. Highly likely by random chance. So the difference right here, even though there's only a difference of 10%, that males think they're like, when you ask them how much funnier are you than the average population, females think, the median female thinks they're pretty much average funny, where the median male thinks they're a little bit funnier than most people. And if you say percent dateable, it's just fun to look through all this stuff. And you can just change the values. Ooh, we got some left skew on it. Who finds this is a smaller difference, more likely by random chance. Males find if we're using median still due to the right skew of the data, you can see a right skew nature. Males find females, or males, or they're finding dateable. Males find more people dateable than females. Males find, depending on whether they date males or females or non-binary individuals, just depending on who they want to date, they find more people dateable than females for this data set. And it just depends on how we ask these questions. And once again, these questions are the way they're asked, is the way the data was collected. You go to a really obvious one. Who do you think is going to have more body piercings? It's like a shocker. Like, pfft. Who do you think is going to have more body piercings? You want a really shocking thing right here? Who do you think has more body piercings? This is like, so the median male, and the male data is super skewed. About vectors, yeah, Angelique, great question. And so males are very, very skewed because most males have 0 body piercings. Like if you look, there's all the males with 0 body piercings. There's 1, there's 2, there's 3, there's 4. Females are more centered around there's 2. It looks like, I think that's where 2 is at. There's 1. And so females have a very large modal area around 2, and then kind of a right skew where males are mainly unimodal here. So definitely we'd compare medians. And you'd say, you know, the median male has 0 body piercings, the median female has 3 body piercings, and there is and this goes back to, and I'll mention this, and we'll go to new questions. Does it make sense to say there is an association between how many body piercings you have and whether you're male or female? This literally ties back to 201 today, where we were talking about associations. And does it make sense to say whether you're male or female would give information, i.e., be associated with your amount of body piercings? And that's what the associate function does. So the amount of body piercings you have is associated with being male or female. It doesn't mean if you're male, you'll have less body piercings. It just means that you say this person's male, it would give you information or mean they are more likely to have less body piercings. Doesn't mean they do. It just means they're more likely, and that you would have a different distribution of probabilities based on it. And you can see right here, the males have more likely to have 0. Doesn't mean they do. This person has 4 or 0, 1, 2, 3, 4. Yep, that person has 4. And then females could have 0, 1, 2, but there's a totally different distribution for females than males. Colton, does that make sense? Hopefully that helped a lot with this question, and kind of some fun data to analyze right here, comparing groups. And definitely we'd use medians right here based on the shapes of these. These are very, very skewed. So we'd want to compare the medians. I think that's got it. Angelique, we'll put that in here. I have a question about vectors and NAs if you have the time. Sure, Angelique, put the full question in the chat. I'm going to put it here. Vectors and NAs. Drop that question. If you have a vector, how would I reassign value? Let's do this. Angelique, I'm just going to drop that right here. Thank you for asking that question right now. So let's call this vector. And I want to see, tell me this. Put it in the chat. You ready? Let's throw some 100 points for those following along. You ready? How could we go to position 2? The values of 2 and 4 equal to NA. Just tell me first, how in the vector could we go to position 2? So how could we go to the position 2 in the vector? So what could I add to this vector right now just to go to position 2? There are safer ways of doing this too. How could I go to position 2 in the vector? How could I go to position 2? There you go. That's position 2. And now if I want to overwrite 2 with NA, I could do that. And now if we look at the vector, I've overridden it with 2. Now you got to be careful. Someone could say I want 2 and 4. But if you go to position 2 and 4, you have to choose both those positions. Does that make sense, Angelique, right there? If you go to positions 2 and 4, let me take a note. We kind of jumped the line on this one since we were in R already. I think we started about right here at 48. And let's say BAS classes. Okay, so now we are overriding positions 2 and 4 with NA, and we can confirm our work right here and do that. But here's the thing: you might want to, like, let's say your vector has things like this. Okay, so now I'm going to do this a little bit differently. Now someone might ask you to reassign the values of 999 to NA. How could I see, and this is a good 201 or good 320 question, how could I see if those things are 999? How could I just see if something is 999 in the vector? So do this in steps. How could I see if something is 999? I just want to look at my vector and know if it's 999. How could I do that? What could I add to line 2 just to see if something is 999? What would I add to this to see if it is 999? So I'm going to reassign the 999s to NAs, but I'm not going to call their positions yet. I just want to first find positions of 999, or find if it is 999. Close. So we want to do a logical test. So we want to do a logical test. Dollar signs connect data frames to vectors. We want to do a logical test to see, is it 999? But I'm into one. Oh, Troy, we're gonna do your question next. Troy, we'll do visualization next. Thank you so much, Troy, for waiting. We'll do Troy's visualization next, right here. And Troy, thank you so much. I think it's gonna be a big help. We'll do visualization number 2 coming up here in a moment. How do we find if something is logically equal to 999? Logical equals. How do we do? Is it logical equal to 999? Logical equals. Logical equals. Logical equals. Close. So logical equals will be this right here. Does that make sense? Throw some points in the chat. Does that make sense? So now we found out if it's logically equals, what do we put in to find which one those are? So how do we find the positions of those? How do we find the positions of those that were equal to 999? How do we find which one those are? How do we find the positions? Like I should find out 2 and 5. I want to know the positions. Close. So we will put it in brackets or square brackets to call positions, but how do we find which ones? That'll be the next step coming up here. How do we find which ones? How do we find which ones? That'll go to position 999. How do we find which ones are the trues? What code gives us which ones are the trues? Oh, well, it is 2 and 5 is the answers. Those are which ones. Great job right there, Kayla. It is which. So which right here returns 2 and 5. And so then, great job, Andrew. Good. 100 points, Andrew, appearing in the chat right there. Andrew, great to see you. Hope you're doing well. And now we go to vector, and then we call those positions, which is just 2 and 5. And then guess what we're going to do? We're going to store NA into that, and then let's check our vector. We just overwrote the positions with 999s. You could, yes, you could use percent and percent. It will work the same way right here. We can check our work right here by doing percent and changing percent and percent. That asks, is it one of these values? Because Angelique, great job. Because maybe we also want to replace the 99s. So let's change this right here to the vector 99. And now this will replace both values. So this no longer says, is it 999? It says, is it contained in the vector 999, 99 or 999? So maybe those are bad values, and now we just replaced both those values right there. So then that says, is something in this vector contained over here? And so you see it returns trues for, well, because we overwrote it. It returns trues for this one, and this one, which are these. It's telling us where these are, and then we can get the positions of them, which are 1, 2, and 5, and then we overwrite those positions with NAs. Does that make sense there, Angeli? And then we'll come back here, Colton, in a moment. Run the no. Is the second output I mentioned the number of the influential points? Run length on that. How many points are influential would be the length of that vector. Great job, Colton, right there. Get the length of that vector. So that vector right there is the point IDs, the identifiers. Those identify the position, the value, the row numbers. Those are identifiers for row numbers. Stat1 identifiers. And then, oh, you got it. Let me know, Andrew. Contact me and let me put you in contact with some people. Contact me and we'll get you. I want to help you out with that, like the best I can. I'll do the best I can to like put you in contact with people because see what we can do. Let's hop back to the main screen. Here we go. It is time for some 201. 201 time, visualization 2. Let's go do some visualization 2. Visualization 2. Oh, we've almost got everything graded. Maybe they haven't unmuted grades. Univariate data. Let's go talk about some visualization 2. Ah, awesome. Nice job, Andrew. Great work. Visualization 2, Stat 201. I love it. We got people from all different classes here. And graduates, all that great stuff. Visualization 2, let's go check it out. Okay, with visualization number 2, we're working on some univariate quantitative data. So univariate quantitative data. I know, right, Patsy? This is the real 201 stuff right here, so we can practice. We've got that diamonds data set again. So let's download the diamonds data set and make sure you've got jump. So number one thing, have jump and go and open it. Now, first thing we're going to do is we're going to take a random sample of our UTID number. Now, what I'm going to do is I'm going to use a different data set than the diamonds data set, which you'll be using the diamonds data set. Make sure to use it. I like to do similar but different work. I'm going to use the Stat201 data over here, which is somewhere on here. Where's that Stat201 data? I thought I had stats one data. Where did data go? Let me find it. Nope. Nope. Did I close all that data? Oh, it's all the way up here. Let me go to... Here we go. We got data open now. Okay, so this is stats tool on data, and we need to do the assignment right here by following through the steps, which have us first create a bar chart. When you create a bar chart, what kind of data are you working with? Big question, good review. When you create a bar chart, what kind of data are you working with? You're only working with one variable, univariate, and that data type is what? Use this graphic right here to cheat. That data you're working with is what? When you're making a bar chart, you're working with this kind of data. So once again, I'm doing a similar but different thing. When you're making a bar chart, you got it right there, Troy. You're working with categorical data. Great job, Kayla. Good practice. Remember, pies of bars, bars of pies. They work for your favorite bars and your favorite pies. Let's go back here to our data. Do we have it in the background? There we go. We'll go to tables, subset. Make sure you have a subset of 300 plus the last two of your UTID. This is the first video. If you need to slow down, make sure to pause. And also check out the first video where we did subsetting to make our unique subset, and take 300 plus the last two of your UTID to get your subset. Check at all times as you're working with your subset to make sure you're working with the right data. To make a bar chart, it's pretty easy. We're going to go to the Analyze Distribution. So I'll pause right here, Analyze Distribution, make sure you have your 300, and then choose, I think, the variable it tells you to choose, which is like cut or something, double check. But I can go right here and get a bar chart of Greek life. And let's go ahead and click OK. And there's a bar chart. Now that we have this, we're going to go to the top right arrow, and we're going to go to stack, and then we've stacked it, and the red arrows are where your options are at. It's pretty easy with point click, right? I hope I can make you like R more, but because R has so many more options. Kayla, stay tuned. I'll show you something at the end of this that we created that I have too much fun with that we created inside of R. Histogram options, and then count axis. Histogram options, count axis. Function R, but yes, Colton, that's exactly it. Colton, 50 points finding. Yep, just finds you all the z-scores instantaneously. So we don't need to find z-scores by hand. We just say scale, and it just tells us the z-score for everything. That's got it. I believe we've done it. I believe we've created a bar chart of Greek life. So once again, make sure to take screenshots that are very easy to see. Now be careful. I'm about to ask you a trick question. Is this skewed to the right or to the left? This is a trick question. Is this skewed to the right or to the left? This is a trick question. So why is it a trick question? Is this skewed to the right or to the left? It's a trick question. You might say, oh, it's a little bit... No, it's a trick question. Because skew only applies to what? It's not. There's not really... Skew is not really applied right here. Not really neither. Why? Because this is a what variable? Exactly, Jessica, 100 points. Exactly. Because it's categorical. This is not like, this is categorical data. Skew is a measure of shape, center, spread, which is for univariate quantitative data. When we talk about shape, center, spread, that's for quantitative stuff. So just remember, going back to reviewing our chapters, if we're talking about quantitative data where it's actual numbers, we can talk about the shape, center, spread of it, which skew is a measure of spread. This one's not that skewed, where this one's a little bit more, and this one's highly skewed. No worries, Patsy. Great job right there, and good practice. So remember, shape, center, spread are measures for univariate quantitative data, and this is univariate categorical, which is just showing us a frequency table and a bar chart. So that should be the first thing. Include a short write-up. Just talk about it. Like, there were 225 people not in Greek life, which represents 63.38% of the population or the individuals we talked to. There are 130 people who are in Greek life, which is 36.6% out of the 355 total. How many numbers did I basically mention as I was walking through this? I kind of also said basically out of the total, which is everything. How many numbers did I mention when I say, for the individuals we talked to, there were 225, which represents 63.38% of the people we spoke to who were not in Greek life. There were 130 people who were in Greek life, which represents 36.62%. This is out of the 355, which is everyone we spoke to. How many of those numbers did I mention? I basically said by everyone we spoke to, which is 100% of individuals, which is 100% of the individuals we spoke to. Now I changed that to a percentage. How many of those numbers do you hear me mentioning in my write-up? My write-up, once again, would be, We spoke to 355 people, and we saw 225 of them who were not in Greek life, which is 63.38%. We saw 130 people who were in Greek life, which is 36.62% out of the 355 we spoke to. So I'm mentioning every number. That's the best thing to do when you do these write-ups, is to mention the values. Oh my gosh. On the project, for the executive summaries, people lose points where they don't mention the values. Mention the values at all times. We're going to give data context. Exactly. I would kind of like talk through it, just mention the values and give them context. Pretend like someone can't see the graphic and you have to explain each number as though someone can't see it. Troy, great answers and great questions right there. Create a pie chart of another variable. Include the labels. I think I include everything on that. Counter percent is fine. Oh, wait. Oh, no. Okay, wait. Watch out, everyone. My graphic is wrong. So crazy. Please, like, I wish I had an alarm thing. Okay. Please make sure to do this. I think I do it in one of the videos. Please tell me if I get something wrong. Yeah, no, they're meant to be straightforward. But I forgot to do something right here. Please start saying something in the chat if I forget. It's not like you have to do these. I mean, the assignment says to do it. But it says include the counts above the bars. So this goes right here to this arrow and go to histogram options and go to show counts. Does everyone see where that button is at? Let me show you again. Make sure to click it. Go here. You don't need that. Histogram options, and then you could go to show counts or percentages. Make sure to click this. Make sure to click one of these two. Don't click them both. But make sure to click that because it says to show the counts. I just don't usually include that in mine because it has account access. But make sure to do that. Please read all the instructions and then go down here to the rubric and make sure you follow this. Like, you see, you could lose. Oh, no. You could lose a point for that. Don't forget that. Create a pie chart from another categorical variable. So we're going to create a pie chart right here. I need to close down jump. So we're going to go to, let's go to the following. I wonder if there's a quick way. I don't think you can change this right here to a pie chart really easily. It's a bummer. I wish it would change into a pie chart. Here's how to create a pie chart is go to graph and go to graph builder. Graph and graph builder. With graph and graph builder, we're just going to once again take a categorical variable, like how far are people away from campus, and drop it right here. So we're just dropping the categorical variable right here. And then do you have a wild guess? Great job, Patsy. Thank you so much for swinging by. Here's some points, Patsy. Great work. Do you have a wild guess of which button I'm going to click up here after I put my data right here? So after I put the data right here, which button do you think we're going to click? Pie button. So there's our pie chart. We're not done yet. We're going to go right here and we're going to go down a little bit on the options. Let me full screen it so you can see. We're going to go to label and label by value, and then we're going to click done. And there you go. Now I wouldn't turn in one this big. I would shrink it down a little bit. And I think that's got it. The round one, right there, 20 points. The round one. So this right here shows us people's distance from campus. We should be good. Make sure to screenshot this. Don't include the whole graph builder thing on it. You can include that, but don't include like the options. You want to click done. Please click done. There's a button that says done. Click that and your screenshot should look like this. Nice and neat pie chart. And so there we go right there. Good pie chart. Include the label. Make sure to click done. A lot of people forget to do that. Yeah, you can use percentages. Yep. Tell me if you think they count off points. See like a label or percentage. Great job right there, Troy. And then just think what we'll talk through. Looking at my data, most people live in the fort. Like the majority of Stats 1 students lived in the fort, with 127 of them living in the fort. The second highest category was people who live on campus with 109. Then there were still a lot of people, 84 of them, within a 10-minute drive. The lesser groups are people who are 10 through 30-minute drive with only 31 people. And the smallest group was people who are 30-plus minute drive away from campus, which represents 4 individuals. Notice once again, how many of these values am I mentioning right here as I talk through? How many of these things did you hear me say as I talk through that? How many of those things did you hear me say? 3-letter word. How many of those things did you hear me say as I talk through this data? As this would be what I would write up. How many of those things did you hear me say? You heard me say what of them? So as I talk through and I'm like, the largest group was 127 individuals, which represent individuals who live in the fort. It's hard to see by the color change. All of them. 50 points right there, just so you're right. All of them are mentioned. So make sure to mention all of them. Make sure to mention the values. Big thing right there. Don't forget to mention the values. Don't forget to mention the groups. Last but not least, we have a histogram, I believe, and we need to do a horizontal layout. We have display options, count access, take a screenshot of the histogram, summaries, and all this good stuff right here, and then include a short write-up identifying the shape. Ooh, first thing we need to do. And then provided a certain shape, then talk about the corresponding appropriate center and spread. So let's go right here and we'll do kind of an obvious one. And we like for test questions to be a little bit obvious. So to do a histogram, one letter in the chat, our data must be what? To do a histogram, analyze distribution, our data must be what? To do a histogram, we're just doing one variable, analyze distribution, our data must be what? Here's a hint. Our data must be what? Yeah, exactly, Troy. Great work there, Troy. If you did percentages, that's good. That's fine too. I don't have a dash. That's weird. That's a data error. Must be quantitative. Must be quantitative for histograms. Histograms, review again, are going to be univariate quantitative displays. So we'll also see a box plot on this. More on box plots in chapter 4 coming up on Wednesday. So histograms are univariate quantitative displays, and that means we've asked a question that's an actual real number. Like, let's ask people, how many pets do you own? So we ask people how many pets they own, and that's the Y variable of interest. And what do you notice about this distribution immediately? And we're going to go to analyze, top red arrow, stack. And then we're going to go to second red arrow. And we're going to go to histogram options, count axis right here. Histogram options, count axis. So top red arrow, stack. Second red arrow, histogram options, count axis. And that gives us the details we need. I like to make this a little bit bigger too and get a good screenshot that looks just like this. I'll screenshot here in a moment. Screenshot, once again, should look something like you can include that one. You can include distributions too, but make sure not to include extra, but the screenshot should look something like that. Something like this. The less it looks like if it's a little different, that's all right. If it's the whole screen or something, that's bad. What do you notice immediately about this distribution? First thing you want to talk about is the shape. And the shape looks like this. Very classic shape to see, easy test question, and not a trick test question. So we write our little helper things right here to make sure we get this. Oh, it's definitely right skew. Great job right there. Definitely right skew. So it's very, very right skew. So since it's very right skew, what is the proper measure of, let's put right here, there's a center here, there's a center here, and this is the measure of spread, and that's another measure of spread. What is the proper measure of center and spread? Since it's very right skew, what's the proper measure of center and spread? The proper measure of center would be the what? So I've highlighted by color coding. So when I talk about this, I would say my distribution is unimodal, centered around what? The mode is generally centered around what? Like the 50th percentile, which is the... We could first identify, we'd say this is a very, very right skew distribution with some high outliers of people who have like 7 pets. Median and IQR respectively, exactly. Median as a measure of center, great job, Jessica. And then IQR as a measure of spread. Who here an instantaneously median of 1. And then make sure to say the median represents the 50th percentile of people who own pets. We see a median of 1 right here. So the median represents the 50th percentile. If the PLU is more than 0.5%, it is likely what we saw right there is by random chance, like differences or something. So Colton, yeah, we can answer a specific question on that. It would depend on what we're testing, but whatever we saw was likely by random chance, Colton. That is true for those p-values. That is very correct. Great job, Colton, throwing those questions. Yeah, I asked those random questions. And then, so once again, the median is the 50th percentile of people who own pets had 1 pet for ownership. The IQR would tell us, and what is the value of the IQR? So the mathematics for IQR is 2 minus 0. What is the value of IQR? It'll be 2. And that would tell us the range of the middle 50% of individuals has a range of 2. The middle 50% of patternships has a range of 2, going from Q1 of 0 and Q3 of 2. So this is Q1 right here, 1/4, and this is Q3. And you could mention those values. And then you've done it. You've talked about the proper center and the proper spread. The only one to worry about is if it looks more normal. If it looks more normal, you'd be in this region, where if it looks more like this, use those measures up there. Who's following along? You can't see it by my head. Who's following along right here on, we thought this was very skewed, so we're using median for center, we're using IQR for spread, but if it had looked more normal, we'd be over there using the mean and standard deviation respectively. But yeah, that's got it. Last question right here for 100 points. Who can give an estimate of the standard deviation using our trick? Now, probably due to the skew, it's a little bit bigger than this, but who can give the estimate trick for standard deviation? I want you to do the estimate trick. Now, it's not going to give you an exact value, but it's like, somewhere around this, like estimate trick. Who knows our estimate trick from class? If you're in the morning class, you heard this. The estimate trick for standard deviation, which we're not using standard deviation, don't put this on your visualization, but it's range divided by 6. This is just an estimate. It's worse the more skewed it is, and it's an estimate of standard deviation. So the range, yep, about somewhere around there, which is not, it's like, So you go 7 divided by 6, and it's that, and it's not right at that, but it's like, it's an estimate. Like, it just gives you a guesstimate of it. Sometimes it's further off, sometimes it's really close. We've seen a few examples today where one it was really close to, sometimes it's a little further off, but range divided by 6. Oh, it's just a way to guesstimate it. But if we really want to solve it, we're going to do the formula by hand. But if we want to do a guesstimate, we take the range and divide it by 6. So remember, we can just solve it right here by solving the formula, and we will never do these formulas by hand. We will always use like programs like jump, or we can just go right here to the standard deviation of this vector, and there's, because we got NA's, NA.remove. Just true. So that's how we solve it in upper level classes. Oh, that's the square root of 2 right there. Or no, it's close to square root of something. Let me square this. Oh, square root of 0.5. Yeah, I've seen that number before. Yeah, it's weird. You see too many numbers, you're like, I've seen that number before. Square root of 0.5 right there. So yeah, because if you square standard deviation, you get variance. So that's the variance. Good stuff. Let's head back to the main screen. Awesome work. What do we got? We got a few more questions. Oh, Kayla, you're wondering about the activity, right? So that's got pretty much the full write-up right there. What were you wondering about the activity, Kayla? Let me know. You're wanting our basics activity. Which things did you want to do, Kayla? Or 201, more questions. I know there's a lot more assignments coming up here. Tomorrow might be a big day for 201. We've kind of got open questions. Troy, you're welcome. Hopefully, did you get the whole visualization done right now, Troy? It's going to be like, visualization done. Office hours visualization done. Kind of talk through it all. Shape, center, spread, univariate, categorical, univariate, quantitative. And then like, it makes more sense to like, okay, that's how we talk about categorical data with the frequencies. Quantitative data is going to have shape, center, spread, but all that good stuff right there. And so, Kayla, which things are you wondering about? We can do some R basics activity. Oh, Kayla, let me show you this. You ready? So here's what we created inside of R, Kayla. You ready? I'll show you real quick. Okay. It's a game. I need to, students been updating this with me. We've been creating stuff. I use some of their code. They use some of my code. But I got to be careful. You ready? Check us out. You ready? How many clicks in 5 seconds? I got to be careful if I play that. I'm going to get like DMCA'd. I've already played it like 10 times. I got to see if I got DMCA'd on this stream already for playing like a millisecond of final countdown. They're like, oh, we can claim this whole stream because you played our music on it. But it plays the song when you play it, and then it shows your clicks right here. We want to actually change it and update it so it shows, like, we could put a bar chart of your clicks. We could have a comparison. We could upload them to a database, and then like, here's how you compare. Oh, that'd be so interesting. Like, it uploads your clicks to our spreadsheet whenever you do this, and then it says like how many clicks you got. Like, here's how you compare. You're in the blank percentile. That'd be cool. I need to like tell my students that, like, let's have it upload to a Google Sheet, and then yeah. So you just click it, and what I need to do, I don't think I have any like I can change it to Rick. So let me change it to Rick right here really quick, where I've got my final countdown. So I need to go to the sound effect right here and change it to Rick, which is... Okay, now it's going to play... Sometimes it cuts out, which we're trying to debug that. But here we go. Watch this. You ready?
Morty, we've got to ace the Stat 201 exam. Morty, we've got to turn the project in early.
There we go. That is Nick Brown doing Rick, and I got 38 clicks in 5 seconds. I've gotten better. I've gotten close to... I think I've gotten higher than 50 a few times. I wasn't ready. I was like laughing and I don't know. But I got to watch playing like Final Countdown on the stream. But we created this right here. We created this code, and I like it does the flashing.
Morty.
Oh, you see, we've had that problem where sometimes the music cuts out. It's generating random colors right there, Kayla. So if you talk about what you're learning in 320, I want you to take a look at this right here. So this function right now, you ready, Kayla? There's a little bit of review for 320. This function right now, this rainbow function, has how many... Oh, probably a lot of yesterday, like maybe 30 minutes was spent clicking a button, see how many clicks I got. It's like you give me a little simple game, I'll just be like, oh, well, how many times I clicks gonna get? So how many arguments does that rainbow function have right there? And we'll learn what the rainbow function does in a second. Don't look at the instructions for it, but look at how many arguments does the rainbow function have? Just tell me that. How many arguments does the rainbow function have? How many arguments does the rainbow function have? How many arguments does the rainbow function have? It has 2, exactly. The first argument is, how many rainbow colors do you want? The second argument is an alpha, which controls the transparency. It's like how transparent from 0 means you can't see them. We don't have a John Cena, you can't see me, but I wish we did. And 1 means they're 100%. So if I do this, I'm making them 50% see-through. Does that make sense what the alpha does? Alpha is a very common argument within a lot of color stuff for the transparency. So the alpha is how transparent is it? Like people talk about like the alpha level, like the transparency of the image. So this makes the colors 50% transparent. Now, how could we use this with Stat 201 is let's make a histogram right here of 1,000 values. And let's add some more bins. Is it bin width? No, wait, breaks. It's breaks. I hate that. It's breaks. Let's do random normal. Okay. Okay, so we're making 1,000 observations. Does this make sense what I've created right here? Let's look at the code I just wrote. How many arguments are in this histogram function? Now, once again, don't overthink it. How many arguments are in the histogram function? How many am I allowed to ask? Yeah, of course. Yeah, of course. Ask away. We'll do it next. You got it. How many arguments are in the histogram function? And I'll show you something cool right here. How many arguments are in the histogram function? Don't overthink it. Just how many arguments are in the histogram function? There's 2. The first one is the data I'm creating, which is random normal, 1,000 random normal numbers. So this creates what this function does right here. It's a function within a function, creates 1,000 random normal numbers. And then the breaks controls the what? 201. Who knows what the breaks controls? And so this is a 201 question. The breaks controls the what of the what. Look as I change the breaks, and you might have heard me mumbling it, trying to find it. Breaks controls the what of the what. So if I go right here and do 1, get that. Breaks controls the what of the what on the bottom. So 201 knowledge right here. Breaks is an argument that controls the what of the what. The width of the what's. So here's very, very big something. Here's very small. Breaks controls the what of the what. Breaks controls the what of the what. The widths of the bins. Oh, let's do that next right here. You got it, Shaze. You got it. It controls the widths of the bins. Does that make sense? So watch this. Width of the bin. Jessica, you got it. Another 100 points. Keep it up. You got it. And so watch this. If I want to change the color of this histogram, I should do what? Brian, you should give it more instructions. You should add an additional what? So think, if I want to control the color of this histogram, I should give it more instructions. I should add an additional what? How do I give it more instructions? You remember that word? Maybe 201 might start remembering it. So I should add an additional what to give it more instructions. So here's the first argument. Here's the second. I should add an additional argument. and I should call color. And what should the colors of this histogram equal? What should the colors of that histogram equal? The colors of the histogram should equal my colors. Does that make sense? I stored something called my colors, and we go right here to my colors, and we do it. And check this out. You ready? You just made a rainbow histogram. There you go. We just made, you want your histograms in R to be rainbow colored? Cool. Maybe you're saying, Brian, your rainbow's not bright enough. Okay. We're going to change the alpha on this. There you go. Well, you say that's too bright. My eyes. Too much. My eyes, in the word of SpongeBob. Okay, we'll lower the alpha. Now you can barely see it. But the alpha argument is just controlling the transparency of the histogram to make either a brighter or more transparent. We could also just take this right here, because that's where the colors are stored, and put that there and just do it in one step. It looks like a lot more now if we break it into just this, but the colors are from a rainbow where we're doing 50 rainbows. We want to go crazy right here. Let's make even a finer one, or we could go to something where it's less rainbow. But does this make sense, Kayla, right here? This is the practice we want to do, at least understanding. But understanding, we could say nbins. We could say nbins equals 50 and store this outside here and run nbins. But now I've got that stored, so I could manipulate this. And this goes to what we're doing with like Shiny, where we can do this. How's this looking to your Discord? May have paid zero attention in my first. All doing is learning how to write. Oh, wait. Oh, no. Is that good? Dylan doing some great work right there. Dylan, we were showing the app that we created right here and talking about kind of the rainbow display. Did you send the updated code, Dylan? Because Dylan was doing some really cool stuff, making the app do even crazier things. All right, let me see. I got to catch up, Dylan. Wait. Do you have, you got some button presses. Oh, Dylan edit final countdown. Well, of course, we're going to check this out. My computer's not a big fan of this. This is just too odd, too slow. Everything seems to be working. So let's say, Dylan, can I show your final countdown? Then we're going to do the question for 201 next. Can I show your final countdown app, Dylan, if you're okay with that? I'm assuming you are. But before I assume, as long as you say, yeah, show it. I want to see your final version, because you were doing some stuff I know with the making multiple colors. So we're going to see Dylan's edits to the app that work. Definitely. That's what I thought. I was 99.99% certain, but I was asked. Let's check this out. Here's Dylan's version. Let me turn down the music. Oh my gosh. It's the final countdown. Oh, and you centered everything. You made it look all nice. Are you ready? I'm not in. I have to I got to be careful. I'm going to get DMCA'd on. Oh, you did it. You did it. You did it. Oh my gosh. You did it. Whoa, this looks way better. Dylan, you did it. Like, let me really play it for real. Did you reset it? All right, let me see if Dylan reset it. All the tasks we wanted. Did Dylan literally complete all these tasks? Dylan, I got to check out how you did this. Okay, ready? Here, real deal. Brian, about to play the real deal game. I got off right there. I went off. Like I said, I've broken 50 quite a few times. I got to play one more time, and then we're doing the 201. Oh, come on. Ah! If I don't break 50, I'm not happy. That was a bad one. That was bad. That's bad. That's bad. That's bad. I quit. I quit midway through. Okay, last try. Like people say, how long did you play this? Forever. Ah, there we go. I don't care. I don't know. We need to now, Dylan. Here's what we need to do next. Got to be 46. It's here, Dylan. We can't play Final Countdown a bunch of times. It looks to still be updating the background right now. I love it, Dylan. We'll have to show this in class. Thank you so much, Dylan. This is great fun. You should show it to Petrie and them. You should be like, we created this Final Countdown app, and we've just been sending it back and forth. And Dylan used his layout right here, which is so nice right here. One more time. All right, here we go. Since we got the record, we got to do it again. You ready? We should have the button update. I had problems with that. Like, that's why you did the two buttons. Okay, here we go. You ready? No, sometimes you get tight as you do it. And so I had a good start. How do you spend off hours? Clicking a button. Nah, it's low 50s. 47. Like I said, I've broken 50. It'd be great to break 60. Okay. Okay, let's do the tool 1 question. Let's go. Oh, what do we do with our time? What do we do with our life? We just click buttons. How many button clicks can you get in 5 seconds? All right, let's do it right here. I really wanted to break 60 right there. But at least I'm getting faster and click every 10th of a second. Oh, we got the music all turned down. We got those DMCAs. Okay, let's do the question. You should show it in class right there. That's a lot of fun. Average chocolate rating. Okay. So when we have average chocolate rating, let's go here to tool 1. Let me take some notes. Average chocolate rating. And let's go right here. BAS 475 shiny apps. And we got time right here for the last one. We'll do 201. 26. Stat tool 1, canvas, content 1, I believe. Okay. So we go. Yeah, what variable type is it? Let's go check that out here on the main screen. Let's go do this. Brian just clicks buttons during office hours. That's all I do. Thank you so much, Dylan. That was really awesome right there. Glad you looked at it and tons of fun right there. I know, right? When you have fun with it and you get the final question, you're like, yes, it works. And I like the way it works. That's what's really awesome. So when we have average chocolate rating, how would we know if it's categorical or quantitative? So when you have a variable right here, and you have here something like chocolate rating and chocolate type and let's say average weight. So we go right here, or we need yeah, sure, average weight. Yeah, cool. And we go here to dark, and rating is something like 8.0, 1.2. How would we know? Like, if we work for a store, how would we know if average chocolate rating? Usually people like milk a little bit more. So this is when we give people, when we sell our chocolate by the pound. Apparently we're pretty off on how we sell it. But when we sell our chocolate, how could we know that chocolate rating? How could we know what kind of variable it is? How could we know what kind of variable it is? So really, it could be categorical, quantitative, or identifier. And so when we're doing this right here, how would we know what chocolate rating is? So categorical means it puts things into categories. So remember, like different groups. It's not a quantitative. Is it not? But think of this, though. How would we know if it's quantitative? How do we know if it's quantitative? It could repeat, but how would we know if it's quantitative? The best way to tell if something is quantitative is to do what? The best way to tell if something is quantitative is to do what? What is the easiest way? If you see numbers and you want to know if they're quantitative, what is the easiest way to tell if something is quantitative? Here, we'll make this 9.0. What is the easiest way to tell if something is quantitative? What's a really good test to see if that is quantitative? Chocolate rating right there. What's a really good way to test if you see numbers to see if it's quantitative? What's a really good test to do? So always remember this test to see if it's quantitative. So how could you, well, it's a number. A number is a good way to check. So it must be a number to be quantitative. And then you could take the what of those to see if it's quantitative. So you could say, well, chocolate rating was 8 for that one, and chocolate rating was 9 for that one. So how can we know if that's quantitative? How can we know if it's quantitative? Kind of, not really add. Good question. You could, I guess, you could. Taylor, that's technically correct. You could sum them, but you could also take their what. So that's correct. And so we could sum or mean them. It is correct. Probably. And so those answers are correct. Usually what I do is I do what? I take the what of the values. Like here, we'll go over to another data set. Usually I find the what of the two values. Like if I look over here and I say someone's age is quantitative and I look at these two people, I could take the what between those two people, because if it's quantitative, I can always do the what between those two people. Age is quantitative. It's how old are you? Like how much is your age, which is a weird way of asking it. But since it is quantitative, I can do what between those two people, which is always a good check to do if you see numbers, to be like, can I do what between this, to say like, oh, these two people right here have a what of this. So difference. So if it's quantitative, you can always take a difference. Could you say right here that milk chocolate had a higher rating than dark by 1 point, could you say that white chocolate had a lower rating than milk by 1.2 points? Sorry, white chocolate's the fat. It's all right. You get a little too much. So could you take the differences between these to talk about there's a very small difference between these chocolates right here. Like a lot of people really like the milk chocolate at our store. So this right here, we could take the differences. So chocolate rating is going to be it's going to be quantitative because it's how much is the chocolate rating. And then the biggest way to know it's quantitative is to know with numbers if we can take their what, it's quantitative. So if we have right here, we know with numbers, it is this. It's quantitative. We can take their what. It's the biggest check. It's quantitative because we can take the what between the numbers. Say it with me again. Kale said it earlier. So if it's quantitative, you can look at the what's between the numbers. Like we were doing that right over here. Or the day was that? The differences. Great job. The differences. That's kind of a key trick right there, is to look at and be like, oh, we could take differences. But people were also correct. If it's quantitative, we can do stuff like the mean. So could we get the mean rating for all these? Could we get the sum of the ratings? Could we get... Those are all actual valid answers. I usually do a difference to say, is high school GPA quantitative? And the answer is yes, because you could say this person has, like these two individuals in the data set right here have a difference of 0.8. Since you can talk about the difference and it's meaningful, like you can always find differences between numbers. But if the difference is meaningful, like there is a 0.8 difference. Now, here's the thing. If we go right here to born in Tennessee, if I go and recode this column as 0, not that, and 1, is this now quantitative? So you see born in Tennessee, I'm going to even do the following. I'm going to purposely make it wrong. Just because, for some reason in jump, this is how it would come in if we brought it in, is this new born in Tennessee, is this new version quantitative? So this is the trick right here. Good practice, and then we'll end office hours here. I think we have class in 18 minutes. Is this now quantitative? So this is born in Tennessee new version, and we've got the original born in Tennessee. Is this now a quantitative variable? Is that a quantitative? Yes or no? Is that a quantitative? Good review of quantitative category. Is this now quantitative born in Tennessee? I see ones and zeros. Those are numbers. So I see ones and zeros. No. It's just categories. It's just group 0, group 1. Colton, does your output look a little bit like... Jessica, and then we'll mention this. We're going to mention Colton's answer. Colton messaged me on Discord. We got a lot of time. I'll probably be doing it like today or tomorrow, but Colton messaged me on Discord, and we'll be talking a lot about that. So, no, that's no. Kayla, 100 points. Keep answering. This is the practice. And Jessica, you're 100% right also, because it's still just group 0, group 1. It's just an alias for yes and no. Does that make sense? There's not a quantitative difference between these two individuals. This is literally just group 0, and this is group 1. Just because it's a number doesn't mean it's quantitative. You have to say, is there a true numeric difference? Yeah, no, I love it. Thank you, Jessica, for encouraging everyone. We're all here to practice. We're all here to remember these things. And truthfully, and I'll just say this, the people who I see doing the best are the ones who even come into practice like 201, 320, 474, 475. Like, just keep practicing. Because like I said earlier, I made mistakes. And Colton, I bet you, Colton, yes or no, when you made your output, are you seeing something that looks like this? When you made your output with that associate function, are you seeing output that looks like this? And are you seeing output that looks like this in your associate function when you ran the associate? I'll show it right here to end the office hours. Were you seeing output that looks like that? I'm going to hit associate, gender, tilde, handedness. Oh, I don't know if I have the data set. Oh, I do still. Were you seeing output that looked like that? You were. 201, he's seeing a what? And he's also seeing a what? What's this over here behind my head? He's seeing a 100 points to end office hours. And we'll swing back to this, Colton. Colton's doing some 201 review right now in the senior level courses. He's seeing a what right here and then a what over there, which is literally what we just taught in the morning class. And we'll be teaching in the afternoon class today. a mosaic plot, and a contingency table. Mosaic and contingency. So exactly, Jessica. Yep. And look right here. There does not look to be an association between your handedness and your gender. Notice how the conditional distributions are very similar. Like, that's horrible text, but ambidextrous left hand and right hand are very similar for male female. P-value is actually very high for classes that have talked about p-values with this. And you can see the distributions right here on the conditional, the marginal and the conditional. Like, this is given someone is left-handed, what's the probability they're male, female? Given someone is right-handed, given someone is ambidextrous, and there's the marginal, which is in the margins. So all these concepts we've been talking about here with marginal distributions, conditional distributions, we can run a very small amount of code, just ask for the association between gender and handedness, and it runs all the output for us and does the answers. And then we just have to know what it means. And it means that what we're seeing here, we'll end with it, it's just likely due to random chance. And that's that p-value that we're learning about. We'll learn about it more later in 201 and in 320 and 474. It's almost time for class. I got to send out the analysis. Bye for now, everyone. We'll be back. Swing by, and thank you, everyone. Great job. Another 100 points. Bye for now. Let me send the announcement while we just play a little music here.
Yeah.